So last class we have started with new topic, that is aldehyde, ketones and carboxylic acid. Okay. So we have started with the introduction. So in the last class we have seen about the nomenclature and structure of carbonyl groups. Okay. So carbonyl group. So which is the functional group in case of aldehyde? It is CHO. Okay. So it is RCHO. Okay. That is R C double bond O H. So at one side you have a carbon atom and another side you have a hydrogen atom to attach to a carbonyl group. So C double bond O is called as a carbonyl group. Then we have studied in case of ketone. So ketone, how it is, the structure is R double bond O R dash. Okay. So there are two carbon atoms attached to carbonyl group. So R can be your alkyl group or aryl group. Okay, R can be your alkyl group or aryl group. So this is the structure of your ketone. So this is a functional group, how you write ketone. Okay, and carboxylic acid R C double bond O OH. So so carbon is attached to one of the R group, that is alkyl or aryl group, and here, okay, the carbon is attached to what? Oxygen. So it is attached to oxygen of an hydroxy moiety, that is OH group. Okay. So it is called as what? This is a carboxylic. So carboxylic acid, they are represented like this. How carboxylic acid are represented like this. So this is aldehyde, ketones and carboxylic acid. Okay. So we have discussed in the class, last class about this. Then we have seen the structure of carbonyl compound in case of aldehyde and ketones. Okay, so the structure, it is a trigonal planar coplanar structure. Okay, wherein the oxygen atom. Okay, so here there are three sigma bonds. So three sigma bonds are formed, and the fourth electron. Okay, the fourth unhybridized fourth electron of the carbonyl carbon, it will be in the p orbital. So this is one sigma bond, this is another sigma bond, this is the third sigma bond. Okay, and the fourth this what valence electron of this carbonyl carbon, it will remain in the p orbital, and this p orbital will overlap with the this what of the p orbital of the oxygen atom, and it forms a pi bond. So there are three sigma bonds and one pi bond is present. Okay, and the angle between this carbonyl carbon and the three other atoms is approximately 120 degree. So when you have a 120 degree, the structure will be a triangular planar. Okay, what do you mean by triangular planar? Like a triangle. Okay, like a triangle. So like this. So this is the triangular planar. Okay. So this is the structure of your carbonyl compound. So this we have seen in the last class. Then we have seen the nomenclature of aldehydes. How do we write the naming? Okay. How to write the names? How to write the IUPAC names for aldehyde? Okay. Common name. Then your IUPAC name. So how it is given. So we have studied it in the nomenclature. Okay, then we have seen nomenclature of ketones. Then we have seen the preparation of aldehydes. Okay, so when you do oxidation, so okay, when you do oxidation of primary alcohol, you get what? You get aldehyde. Okay, same way when you do oxidation of methyl benzenes. What do you mean by methyl benzenes? Benzene with a methyl group. It is also called as toluene. Okay, so toluene. So AR is nothing but your aromatic compound. So when you have aromatic compound with a methyl group, okay, so this oxidation is taking place in the presence of chlorine, okay, Cl2 and heat. Okay, so it is undergoing a free radical mechanism. So what type of reaction it is going on? It is undergoing a free radical mechanism. Okay, so it forms ACHCl2, that is AR is a aromatic ring, CHCl2. Then when you do hydrolysis, it is converted CHCl2, it is converted to what? Aldehyde. Okay, so here we are doing the oxidation. Then reduction, what do you mean by reduction? Reduction is nothing but you are doing what? You are doing, uh, you are adding hydrogen. So addition of hydrogen is called as what? Addition of hydrogen is called as what? Reduction. It is called as reduction. So addition of hydrogen is called as reduction. So you have acid chlorides. So this is the acid chloride. So when you have acid chlorides or when you have aliphatic acid chloride, that is R, if your R is an alkyl group, or if you have a aromatic, okay, compound. So when you treat it with lithium aluminum hydride, so what is lithium aluminum hydride? So lithium aluminum hydride is a reducing agent. It is a strong reducing agent. So it converts your acid chloride, okay, into aldehyde. So it converts it into aldehyde, respective aldehyde. Okay. So the this way your reduction takes place. So this was another preparation from where you can prepare your aldehyde. Then this was the next preparation of ketones. Okay, preparation of ketones was what? Dehydrogenation of secondary alcohols. So when you take a secondary alcohol and you do dehydrogenation, so I have said what is dehydrogenation. Dehydrogenation means removal of H2. Okay, H2, removal of H2, that is hydrogen. Okay, so when you are removing hydrogen, that is H2 molecule, then it is called as what? Dehydrogenation. It is called as what? Dehydrogenation. Okay, so dehydrogenation of, so dehydrogenation of secondary alcohol. So when you have a secondary alcohol and you do dehydrogenation, that is in the presence of copper, okay, at a temperature of 573 Kelvin. So this secondary alcohol is converted to your ketone. Okay, it is converted to what? It is converted to ketone. Okay, it is converted to ketone. So dehydrogenation means what? There is a removal of H2. So this H2, okay, there is hydrogen removal. Okay, so this results into your, okay, so this is dehydrogenation reaction. So wherein what is happening here? Dehydrogenation means there is removal of hydrogen. Okay, hydrogen molecule. Next is hydration. Okay, next is hydration. So what do you mean by hydration? Hydration means addition of water. Hydration is addition of water molecule. Okay, hydration is addition of water molecule. So what we are doing, we are taken a alkyne here. So when you are taken alkyne, you are adding water. So it is undergoing a Markovnikov rule. Okay, so OH is added to the carbon having least number of hydrogen, and so here one hydrogen is here. There is no hydrogen. So OH is added here, and here your hydrogen is added, then it undergoes tautomerism. What do you mean by tautomerism? Tautomerism means what? The number of atoms are same, only there will be what? The change in the structure. Okay, here you see it is a alcohol, OH. Here it has become to ketone, right? So tautomerism means what? Only change in the bond. Okay, change in the bonds. So here you can see, so it is alcohol is converted to ketone. The number of atoms in both this is same. So it is undergoing a ketoenol. So this is a keto form and this is a enol form. Okay, in, because in is one double bond is there and one OH is there. So it is all. So it is a ketoenol form. So whenever it is undergoing tautomerism, it will show what? It will show you ketoenol form. Okay. So this is your hydration reaction. Then we have seen ozonolysis. So what we have done in ozonolysis, we have added a molecule of ozone across the alkene. Okay. So then we have seen about the physical properties. So last class we have again started with the important reactions. So these reactions are very important, name reactions. So we have seen the Rosenmund reduction. So we'll just glance it and then we'll go further. Okay. So Rosenmund reduction. What is Rosenmund reaction? So you have taken a acyl chloride. Okay. So remember what is acyl chloride here? What is acyl chloride? So we have taken the example of benzyl chloride. So whenever you have R, C double bond O, Cl. So this bond, C double bond O, Cl. Okay. Whenever you have a C double bond O, Cl, and you are doing hydrogenation. Now, what do you mean by dehydrogenation? Dehydrogenation means removal of hydrogen molecule. Okay, H2 molecule. Hydrogenation means addition of H2 molecule. Okay, so it is what? Addition of hydrogen. So what you have done, we have adding to hydrogen in the presence of a catalyst. The catalyst taken is what? Palladium and BaSO4. Okay, it is what? Palladium in the presence of barium sulfate. So this your benzyl chloride. Okay, that is your acid chlorides is converted into CHO. It is converted into what? CHO. That is, it is converted into aldehyde. So this is what? This is a name reaction called as Rosenmund reduction. What we are doing in reduction, we are adding hydrogen. So what we are doing? Addition of hydrogen. Okay. So this is a reduction reaction. So I hope this is clear. So name reactions are very, very, very important. Okay. Next is Stephen reaction. So what we are doing in Stephen reaction? Yes, what we are doing in Stephen reaction? So in Stephen reaction, we have taken nitriles. What do you mean by nitriles? Nitriles, or it is also called as cyanides. Okay. Nitriles, or it is also called as what? Cyanides. Cyanide group. CN is what? CN is a cyanide group. So it is also nitriles, or it is also called as cyanides. So what cyanides are reduced? Okay, your cyanide group is reduced to what? It is reduced to imines. Okay, what is imine? CH double bond NH group. Okay, whenever you have CH double bond NH group, so this is called as imines. Okay, so your nitriles, okay, nitriles are reduced. Okay, reduced means what? You are adding hydrogen. So here you can see RCN, okay, is converted to R HCNH. Okay, means what? Your cyanide group is what is done here. There is no hydrogen. Here you can see there are two hydrogens. So what we are doing? We are adding hydrogen. Reduction means you are adding hydrogen. So nitriles are reduced to imines with which is the agent? It is stannous chloride. Okay, so which is a reagent which we are using for reduction? So for reduction, the reagent which we are using is stannous chloride in the presence of HCl. Okay, that is hydrochloric acid. So nitriles, they are reduced or they are reduced to corresponding imines with the stannous chloride in the presence of hydrochloric acid, that is HCl. So this imines, okay, the imines which is formed, it is further undergoing hydrolysis. It is undergoing acid hydrolysis. Okay, acid hydrolysis means what? Acid hydrolysis means in the presence of acid. Means it is undergoing hydrolysis in the presence of acid. We are adding water molecule. So it is converted to aldehyde. It is converted to aldehyde. So remember the steps in stiffened reaction. Okay, in stiffened reaction, what is the steps? Nitriles, they are reduced to corresponding imines. Okay, nitriles are reduced to corresponding imines. Okay, in the presence of what? In the presence of stannous chloride and hydrochloric acid. Okay, these imines are further what we are doing? We are doing acid hydrolysis. Okay, and it is converted to aldehyde. So this is the steps you have to remember. Okay, so next is Ithard reaction. So next name reaction is Ithard reaction. So what we are doing in Ithard reaction? We have taken the starting reactant is our toluene. Okay, toluene. Toluene is what? Benzene ring with a CH3 group. Okay, benzene ring with the CH3 group. It is also called as methyl benzene. Okay, the common name is what? Methyl benzene. So what we have done, we have taken methyl benzene or the toluene. We are treating it with a chromyl chloride. Okay, we are treating it with chromyl chloride. So what we are doing here, this is a oxidation reaction. Oxidation. Chromyl chloride is a good oxidizing agent. Okay, what is the role of oxidizing agent? Now, Rosenmund reduction and Stephen reaction, both the reactions were reduction reactions. Okay, we were adding hydrogen. This is good oxidizing agent. So what it is doing here? We are adding oxygen. What we are doing? We are adding oxygen. So toluene, okay, we are treating it with chromyl chloride. So what is the formula of chromyl chloride? CrO2Cl2. Okay, CrO2Cl2. So we are treating toluene with chromyl chloride, that is CrO2Cl2. So what is done? This methyl chloride, what is there? Okay, methyl group. So that is oxidized to chromium complex. So it is converted into chromium complex. Okay. And this chromium complex which is formed is further undergoing hydrolysis. It is undergoing hydrolysis to give you benzaldehyde. Okay. So this is the another oxidizing age reaction. So Ithard reaction, remember, it is the oxidation reaction. It is what? It is the oxidation reaction wherein the reagent which we have taken is what? It is chromyl chloride. So chromyl chloride is a reagent wherein we are oxidizing our toluene group, that is CH3 is converted into a intermediate complex, that is chromium complex, which on further hydrolysis will give you benzaldehyde. Okay, so this is a Ithard reaction. So Ithard reaction is very important reaction. Next is next reaction is Clemmensen reduction. So Clemmensen reduction, the name it will tell you. So this is a reduction reaction. Okay, reduction means what now again? Reduction means addition of hydrogen. Addition of hydrogen or removal of, okay. So or it is what it is called as what? Removal of oxygen. Okay. So Clemmensen reduction. So we are doing reduction now. So Clemmensen, another name reaction. So what we are doing here, we have taken carbonyl group. Okay, here we have taken carbonyl group. So carbonyl group we are treating. Okay, we are reducing it to your alkane. Okay, that is CH2 group. We are treating carbonyl group, that is C double bond O group, is converted to what? CH2 group. So what is done here? Removal of oxygen, addition of hydrogen. So this is a reduction reaction. So what we are doing, we are reducing our carbonyl group of aldehyde. Either you can take a aldehydic group or you can take a ketonic group. So it can be a aldehydic group or ketonic group. So it is reduced to CH2, that is, it is reduced to alkanes. How it is reduced? So Clemmensen reduction, you need to remember the reagent. So which reagent we are taking? We are taking zinc amalgam and concentrated HCl. So which is a reagent which we are taking? Zinc amalgam. Okay, zinc amalgam means what? ZnHg. Okay, zinc amalgam in the presence of concentrated hydrochloric acid. Okay, it gives you alkanes and water molecules. So very important name reaction. So remember this name reaction, very important. So you need to remember the reagent. So what is reduced in Clemmensen reduction? Your carbonyl group is directly reduced to your alkanes. C double bond O is reduced to CH2, which is the reagent zinc amalgam in the presence of hydrochloric acid. Okay, so Clemmensen reduction. Next, one more important name reaction, Wolff-Kishner reduction. So this is also a reduction reaction. So Wolff-Kishner reduction. So what we are doing here, again same, we are converting our carbonyl group, that is C double bond O group, to alkanes. Okay, CH2 group. So what we have done, we have converted uh, our carbonyl group. Okay, we have converted our carbonyl group to alkanes. Okay, so what we have done, we are treating it with hydrazine. Okay, what is hydrazine? NH2 NH2. Okay, NH2 NH2 is hydrazine. Okay, hydrazine followed by heating with potassium or sodium hydroxide. So it is a strong base. So what we are doing, we have taken a hydrazine and we are heating it with either potassium or sodium hydroxide. So what is potassium or sodium hydroxide? It is a strong base. Okay, it is a strong base. Okay, in boiling solvent like ethylene glycol. So which is the solvent taken here? Ethylene glycol. So we have taken, we are going to heat, we are treating hydrazine. Okay, so your carbonyl group is treated with hydrazine followed by heating it with potassium or sodium hydroxide in a boiling solvent like ethylene glycol. It is converted to your CH2. So remember the reagents. Okay, remember the reagents in both the case. So here in both the case, you can see carbonyl group is converted to CH2 group. CH2 carbonyl is converted to CH2. Now there can be a question. What is the reagent used in Clemmensen reduction? Okay, for reducing your carbonyl group to CH2 group, which is the Clemmensen's reagent? Okay, so what you have to tell? Zinc amalgam. Okay, zinc amalgam in the presence of HCl. Okay, so Clemmensen's reduction, which is the reagent used? It is zinc amalgam and HCl. And in Wolff-Kishner reduction, which is the reagent used? It is hydrazine. Okay, hydrazine in the, it is treated with hydrazine followed by potassium hydroxide, or you can take sodium hydroxide. okay, in the presence of solvent like ethylene glycol, okay, in the solvent like ethylene glycol. So it is heated, okay, it is heated. So this is the reagent. So please remember the reagent. So these two named reactions are very, 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 very important, okay. So remember the reactions. Next, aldol condensation, one more very important reaction. So there are many name reaction in this chapter, and that is all are very important, okay. So aldol condensation, aldol, okay. So what we are doing here in aldol condensation, so aldehydes and ketones that have at least one alpha hydrogen, so it should have at least one alpha hydrogen. Okay, so so aldehyde and ketones having at least one alpha hydrogen. Okay, now I'll explain you what do you mean by alpha hydrogen. So it condenses in the presence of dilute alkali. So we have taken a dilute alkali here, okay, as a catalyst to form para hydroxy aldehydes, aldols, or para hydroxy ketones. Okay, just a smelling mistakes. I'll do it. Para hydroxy aldehydes or para-hydroxy ketones. Okay. So aldehydes and ketones, they have at least one alpha carbon. Now, what do you mean by alpha carbon? Okay. Now, here I have a reaction. You can see here. So, 2CH3, C double bond O, H. Okay. So, does it has a alpha carbon? Yes, no. So, it has a alpha carbon. So, this is alpha carbon. So, it has one alpha carbon. So what we are doing, so either the aldehyde or a ketone, so it should have a alpha carbon. So if it has a alpha carbon, so there are three carbons. So out of this, one can be used. So aldehyde and ketones, which have at least one alpha hydrogen, it condenses in the presence of dilute alkali. So we are going to take alkali here. Okay. Alkali means what? Base when it is dissolved in water. Okay, it gives you alkali. So when you are dissolving your base, okay, when you're dissolving your base in water, it gives you what? It gives you alkali. So alkali will be very strong. Okay, they will be very strong. Strong means they are what? They will easily produce the uh, uh, what you can call, base will abstract the proton, so it will form the, so base will produce abstract the proton, and you can easily form the carbon ion. Okay, so now this alpha hydrogen is taken from this, so I can write it like this also, just a second. So it is CH2, okay, like this, C double bond O H, right. So here what we are going to do, we are going to treat it with dilute NaOH, that is sodium hydroxide, and it will going to abstract this proton. Okay, when it abstracts this proton, okay. So what will happen here? So it undergoes, so this aldehyde and ketones which are having alpha hydrogen will undergo self condensation because there are two molecules, right? There are two molecules. So how you will write it? I'll just show you. So there are two molecules of acetaldehyde. So one acetaldehyde will be CH3, C double bond OH. Another will be, you can take it as CH, CH3, C double bond O, H. So these two aldehydes, okay, they will undergo self condensation in the presence of dilute alkali, okay, as a catalyst. So this is acting as a catalyst, and it forms what? It forms beta hydroxy. This is beta. Okay, it forms beta hydroxy aldehyde or beta hydroxy ketone. So thus it is called as aldol condensation. Aldol condensation, it is a self condensation. Okay, between two aldehydes or between two ketones. What is the necessary condition? At least one of the aldehyde or ketone should have a alpha hydrogen. So this is only the necessary condition, and it undergoes in the presence of dilute alkali. Okay, so now, so this will be treated in the presence of dilute NaOH. So NaOH, okay. Now what you will get? You will get, hmm. So now what will have? So one of the aldehyde should have a alpha proton. So you see here, okay, just see here. So this will be CH2. Okay, I'll take CH. Now what will happen? This will form negative. So this NaOH, okay. So this OH will abstract this proton and it will become CH2. This CH2 will attack this carbonyl carbon and it will form like this. So I'll write the reaction now. CH3, C, okay, then O, then here it will be CH, here I'll write CH2, then this will be C double bond O, H, and here it will be H. Understood? So like this, okay. So this H will be here. So this will form what? Now this is ketone, this is your alpha carbon, this is your beta carbon. So it is forming what? It is forming hydroxy, beta hydroxy aldehyde. Okay, it is forming beta hydroxy aldehyde. So what is the name? It is acetaldol. Okay, it is called as acetaldol. Fine. So this beta hydroxyaldehyde or ketone, further it will undergo dehydration, that is removal of water molecule when you heat it. So what will happen? From this your water will go, and from here your hydrogen will go, and it will form what? It will form CH3C. Okay, and it forms a double bond. So C double bond, CH double bond, CH, C double bond O H. So this is your but two in all. Aldol means what? There will be one a double bond and one carbonyl group. Okay. So it is called as a aldol condensation. One more reaction shall solve at the behind. Okay. See this, we have taken a ketone. Okay. Acetone. So with this I'll solve. Okay. Here I'll solve. Okay. Now here you see how to write for ketone. So either the aldehyde or ketone. Okay. So you are going to take it with what? You are going to take two molecules. You are going to take two molecules. So I'll take one more CH3, C double bond O, CH3. So this reaction will undergo in the presence of strong base like NaOH. So this will undergo in the presence of strong base like NaOH. Okay. Now, what is this? It is acetone. Okay, it is acetone. So acetone in the presence of dilute NaOH, that is, it is a strong base. So what is happening? So here there will be abstraction of proton. Okay, and it will form a carbon ion. So this will attack here, this in further like this. So this will be CH3, C, O, H. Okay, this will be H. This will be CH2, C double bond O, CH3. Okay, like this. Understood? So this is what our alpha, this is beta. So it is beta hydroxy ketone. Okay, it is beta hydroxy ketone. Now this beta hydroxy ketone, what we are going to do? We are going to heat it. Okay, when you heat it, what will happen? Water molecule will be lost. Okay, water one molecule will be lost. Water molecule. So water molecule, how it will be lost? So this H. So I'll rewrite it just here. Okay, so this CH2 is there, no? So this CH2 can be also written as this. So CH2, so this is CH2. 3. Okay, so this C, H, and this is one H, and here is this is one CH3, this is CH3, C, double OH. Okay, this is CH3 again. So this will be CH3. Now what will happen? So this is alpha, this is beta. So this is alpha, this is beta. Okay, this is alpha, this is beta. Now what will happen? This water molecule will be lost from here. This will be CH3, C, H, double bond, CH, C double bond O. No, here your CH3 is there, no? So CH3. So CH here, I'll show you once again. Okay. Now when your water molecule will be lost here, okay, loss of water molecule. So your from here hydrogen will go and from here OH will go. Okay. Now you write remaining CH3 C. Okay, CH3 C, then here CH3, then double bond C H, then C double bond O CH3. So it is forming what? It is forming what is the name now? So if this is 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3, 4, and 5. So it will be 4, 4 methyl. Okay. Then 5. So it is pent. Then 3 in and 2 on. So this is the name. So this is the aldol condensation. Very important name reaction. So aldol condensation is very important name reaction. Remember. So aldol condensation is very important in your theory also. Okay, for your board exams also, this is one of the very important question which can be asked. Okay, so we have seen the next is Carin-Zaro reaction. Okay, another name reaction which is very important, that is Carin-Zaro name reaction. So Carin-Zaro name reaction is what? So Carin-Zaro name reaction. So aldehydes which do not have a alpha hydrogen. So whenever okay, so uh, whenever you do not have a alpha hydrogen, so when, some molecules they do not have alpha hydrogen, so that time, okay, so that time what you have to do, so that time these aldehydes which do not have alpha hydrogen atom, they undergo self oxidation and reduction. Okay, reaction on treatment with concentrated alkali to yield carboxylic acid, salt, and alcohol. So aldehyde, you can see there is no alpha hydrogen. So this is formaldehyde. So when formaldehyde, two molecules of formaldehyde is treated with concentrated KOH, it is giving what? It is giving you a salt of, okay, and this is a alcohol. Fine. So one example is given. If you take benzaldehyde and you treat it with NaOH, you get benzyl alcohol and sodium benzoate. So you get a corresponding salt of carboxylic acid and you get a alcohol. Okay. So this is the some of the very important name reactions of aldehyde and ketones. Next, we are going to see acidity of alpha hydrogens of aldehydes and ketones. Okay. Now, due to acidic nature of alpha hydrogens, that is alpha hydrogen of aldehyde and ketones, they undergo a number of reactions. They undergo number of reactions. So this acidity is because of strong electron withdrawing nature of the carbonyl groups and resonance stabilization of conjugate base. So because of this presence of alpha hydrogen, they undergo they undergo number of reactions. Okay, so why they undergo name under many reactions? Because This acidity is because of the strong withdrawing nature of carbonyl group. As you know, this carbonyl group is a strong withdrawing group. Okay, so because of this strong withdrawing group, it has the alpha hydrogens. Okay, the alpha hydrogen is very acidic in nature. They are very acidic in nature. Thus, they undergo n number of reactions. Okay, so because of this, because of the carbonyl group, it can undergo resonance stabilization also. Okay, if there is abstraction of base, so this base and the carbonyl group can undergo resonance stabilization with the base. Okay, so this is the acidic behavior of alpha hydrogen. Next, what are the uses of aldehydes? So in laboratories, formaldehyde is a common chemical which is readily formed. So in okay, so in the laboratory, we can get easily formaldehyde. So preparing a 40% solution of formaldehyde is water is the primary usage of uh, formaldehyde. So you can easily prepare 40% solution of formaldehyde in water. Okay, it is a primary usage of formaldehyde. Next, aldehydes, they serve as precursor. Okay, precursor in various industrial processes such as glue preparation. So, you know, in glue preparation, okay, your gum bottles. So, for the preparation of gum bottles, so this aldehydes, they serve as a precursor. Okay. So they prefer they serve as a precursor, okay, in the producing of glue preparation, then tanning and polymeric goods. So what do you mean by tanning? For woods, okay, for woods they give black paints, right? So they don't do tanning for that. Then also your cosmetic. So cosmetic and dye industries and perfume and fragrance companies, they rely heavily on aldehydes for their product formulation. So for product formulation, your cosmetic dye industries and your perfume industries, fragrance companies, so they heavily depend completely on the aldehydes. Then in addition to photography and drug testing, formaldehyde is also employed in the manufacturing industries. Okay, so these are some of the uses of aldehydes. Next is the uses of ketones. Okay, so acetone is the easiest, what you can say it is available. So acetone, it is the most common, and it is easily available in your laboratory. Okay, and it you can easily handle acetone. Okay, among all the ketones, you can easily handle your acetone. So in your thinner, okay, paint thinner, that is when you are using paints for walls. Okay, so in that thinner also acetone is prepared. Acetone will be there. Then you are when you are removing the nail paint, okay, when you are removing the nail paints also, so for removing the nail also, that time also what you require, you remove with a remover. So in that remover also, for to remove the nail paint, so that remover also consists of your acetone. Okay. Then in case of some types of synthetic fibers and plastic, ketone solvents are particularly effective. In addition to treat opiate addiction, okay, ketone methadone is a kind of ketone. An excessive quantity of dopamine hormone is released after using opioids. Because methadone interacts with the dopamine receptor in the brain, it can break the user's physical dependence of opiates. Okay, so this is another use. The human body and other living species, they require many ketones to function well. So progesterone, testosterone, cortisone, and androsterone. So these are all the steroid hormones, and they are all ketones. So some of the steroids, okay, when some of the hormones, that is steroid hormones. So these are all, they are the ketones itself. So next we are going, so by this we have completed aldehyde and ketones. So next we are going to see is the carboxylic acid. Okay. So carboxylic acid, you know what is carboxylic acid? So they are also the organic compound which contains C double bond OH group. Okay. So which is attached to a R group. So R can be your any alkyl group or a aryl group. Okay. Then this carboxylic acid group, that is COOH group. So this is commonly referred as what? It is referred as carboxyl group. Then how it is expressed? It is written as RCOOH. Okay. and this carboxylic group, they are acidic in nature. So how they are acidic in nature and they have polar in nature. Okay, because R C double bond O OH. Okay, so this will tend to, okay, so they can also participate in hydrogen bonding. Okay, they can also participate in hydrogen bonding because of the presence of electronegative O oxygen atom and hydrogen. So they can participate in hydrogen bonding. So accepting nature of carbonyl group and the hydrogen bonds donating nature of the OH bond. So they are having higher boiling points. So they generally have higher boiling points when compared to water and tend to form stable dimers. What do you mean by dimers? Dimer means they are like this. Okay. Suppose Al, Cl, Al. Okay. Cl. So this is dimer. Okay, so this is the dimer. So they form like this, dimer form. Okay. Then carboxylic acid, they play very important role in the production of pharmaceuticals, food additives, solvent and polymers. So they play very important role in these all processes. Then acetic acid, adipic acid, citric acid. So these are some of the carboxylic acid. So where acetic acid is formed in your vinegar, okay, in the vinegar, acetic acid is present. Then citric acid in the citrus fruits like lemon, oranges, right? So, so these are extremely useful in industries. Okay, so these are some of the acids. So what are the physical properties? So aliphatic carboxylic acid up to 9 carbon atoms, they are colorless liquids. So up to 9 carbon atoms, they are all colorless liquids at a very room temperature. Okay, and with unpleasant odor. So the smell is not good. Okay, it has a unpleasant odor. Higher acids, they are wax-like solids and they are odorless, no smell. Okay, odorless means they do not have any smell and they are less volatile. Okay, they are less volatile. Less volatile means they won't easily evaporate. Okay, they are less volatile. The boiling points of carboxylic acid are higher than aldehydes and ketones. So the boiling point is higher of carboxylic acid or than the aldehyde and ketones and even alcohol. So carboxylic acid, it has a higher boiling point than aldehyde, ketones and alcohols because of the comparable masses. Okay, and because of intermolecular hydrogen bonding. So when you're comparing the molecular masses, okay, so because of molecular masses also and because of the intermolecular hydrogen bonding, so it will have a higher boiling point. These hydrogen bonds are not broken completely even in vapor phase. So when this carboxylic acid, so even these carboxylic acid, they do not break even in the vapor phase. Okay, so they exist as dimers. So they are existing in dimer form. Okay. Then simple aliphatic carboxylic acid up to 4 carbons, they are miscible in water. What do you mean by miscible in water? They are soluble in water. Okay, up to 4 carbon. Aliphatic means straight chain compounds. Okay, straight chain carboxylic acid compounds up to 4 carbons. They are soluble in water. Why? What is the reason why they're soluble? Because of hydrogen bonding with water. Because they can easily form hydrogen bonds with water. So they are simply miscible. As the number of carbon atom increases, so as the number of carbon atom increases, what will happen to solubility? Solubility of carboxylic acid will decrease. Okay, so only up to 4 carbon, it can be easily soluble. Why? Because of hydrogen bonding. As the number of carbon atom increases, what will happen to solubility? It goes on decreases. Then higher members of carboxylic acid, they are insoluble in water. Okay, higher members of carboxylic acid, they are insoluble in water because of increased hydrophobic interaction of hydrocarbon part. So as the number of carbon increases, okay, what will happen? There will be hydrophobic interaction. Okay, the hydrophobic means which is water heating. So that will be attracted towards the hydrocarbon part. Benzoic acid, which is the simplest aromatic carboxylic acid, is insoluble in cold water. Then carboxylic acid, they are soluble in less polar solvents like benzene, ether, alcohol, chloroform, and so on. So these were some of the physical properties of uh, carboxylic acid. Okay, next is the structure of your carboxyl group. Okay, that is your COOH group. So the carboxylic group of carboxylic acid, they comprise of carbonyl group, right? So you know that how is the structure. So this is a structure, right? So in the structure, what you can see, so what you can see in the structure, so one is your carboxyl group and one is your OH group, that is a hydroxyl group. So one, it is a carbonyl group is present and one hydroxyl group is present. So in the carbonyl group, both the carbons, okay, both the carbon and oxygen, they are sp2 hybridized. Okay, in carbonyl group, both the carbon as well as your oxygen. So these carbon and oxygen are sp2 hybridized. What do you mean by sp2? Whenever they have a double bond, right? So it is linked with a double bond, so it is sp2 hybridized. The oxygen atom of the hydroxyl group is also sp2 hybridized. Okay, the carboxyl group, it has a trigonal planar is like this. So it has a triangular planar, okay, structure. Then one of the lone pairs of electrons of oxygen, okay, they get conjugated with the pi system of carbonyl group. So because of this lone pair, so it can form a conjugate system like this. I'll show you. So R, C, double bond O, OH. So one of the lone pair of electrons, so it undergoes in the conjugate system and it can form R, C, O minus and double bond O, H. Okay, like this. So like this. So it can undergo conjugate system. Fine. So the bond angles of the carboxyl group is approximately 120 degrees. So this is the structure of your carboxyl group. Okay. Next is, what is the acidic strength of carboxylic acid? The acidity of carboxylic acid, it is higher. Okay, it is higher in comparison to phenols as they react with weak bases like carbonates and bicarbonates, and they liberate carbon dioxide. Okay, the carboxylic acid, they are acidic in nature. Why? Because of the hydrogen in carboxylic group. So because of the hydrogen in the carboxylic group, which can be given forming the carboxylate ion. So because of this hydrogen, it can form what? So because of this hydrogen, they are very acidic in nature because they can form carboxylate ion. Okay, it can form carboxylate ion. So acidic strength, it is highly acidic in nature. Okay. Then what is the nature of carboxyl group of carboxylic acid? As stated earlier, the carboxylic group of carboxylic acid, it is made up of what? It is made up of one carboxylic group and one hydroxyl group. The carbonyl group of carboxylic acid, they behave differently from that of aldehydic and ketones. Okay. Then the carbon in carboxylic acid is less electrophilic than that of the aldehydes and ketones. So when you're talking about the carbonyl group in case of uh, aldehydes and ketones, it is less electrophilic. Okay. Uh, then that of, so carboxylic group, that is carbonyl group in the carboxylic acid, it is less electrophilic in nature. So this is because of what? This is because of the presence of resonance in the molecule. So because of the presence of resonance in the molecule, which will make the carbon atom of the carbonyl group very less positive, and thus it will be less electrophilic in nature. So this is some of the important key features of carboxylic acid. Okay, whenever you are naming the compound, that is carboxylic compound, so what you have to write? You have to write what? You have to write your oic. Okay. How for aldehydes we write al. Okay. And for ketone we write on. So E should be in this. E should be replaced with oic acid. Okay. It will be replaced by oic acid. That is OIC, oic acid. Okay. Then for example, C3H7 is called as butanoic acid. E will be replaced by your oic acid. So even if there are other substituents present, the carboxylic acid can be considered as the first position of the parent chain as seen in the name of the. So here you can see whenever you are having other groups also, so your carboxylic acid, it should be considered as the parent chain and you can give the name. Okay, and you can give the name for that. Okay. So for if you have H HCOOH, okay, that is formic acid. Common name is formic acid. What is the name? It is a ethanoic acid. It is a ethanoic acid. छान जास्त करू नको. Okay, so here you can see it is acetic acid, propanoic acid, benzoic acid. Okay, so here this is a carbonyl group and this is a hydroxyl group. So these were some of the key points of your carboxylic acid. Okay, so in this chapter we have studied some of the important name reactions about aldehyde and ketones, right? And today we have started with the carboxylic acid. So this completes your synopsis part. Okay, this complete your synopsis part of aldehydes and okay. So this completes your synopsis parts of aldehyde, ketones, and carboxylic acid. So in the next class, we'll be seeing some of the MCQs based on this chapter. Okay. I hope this is clear. So the synopsis part is clear. Yes. Okay. Fine then. So in the next class, we'll solve some MCQs based on this particular chapter. Okay. For in tomorrow's class, we'll solve. Okay then. So any doubts you have, Priyanka? If you have any doubts, you can ask me. Okay then. So I shall end the session here. Okay. So I shall end the session here. So we'll meet in the next class. Thank you.